We focus on providing a practical tool, offering solutions so that at the very least the client doesn't have to worry.
First, an assessment of the company is carried out, identifying key technological points where any failure would be especially critical for the company's profits.
This type of analyzer requires personalized customization, adaptation for each client, linking to a specific physical location where it will be installed, integration with the enterprise's upper-level systems, and thorough methodological development.
To be honest, most factories were established in the 1930s or 1950s. And this means that the tools, well, everything used in flotation, were designed specifically for that period of time. Failures often occur at all of these stages. As a result, so to speak, the shareholders' directive is fulfilled by making a purchase. But despite all this, the desired result is not achieved.
To communicate that we are ready to share and help and how to avoid such situations. Year after year, we receive inquiries from a number of companies that lack experience operating this equipment and make very costly mistakes. My name is Arseny Trushin. I am the director of a company specializing in the production of science-intensive, high-tech elemental composition analyzers for process streams. I hold a PhD in physics and mathematics and have 2 higher education degrees. We have been working in this field for over 13 years. Vyacheslav, the floor is yours.
Yes, thank you. My name is Vyacheslav Titenko. I am 52 years old and I have dedicated more than 30 years to the company Norilsk Nickel. For the past 5 years, I have been focused on improving operational efficiency, working in the business systems development department under the leadership of Mamontov Alexandrovich. I am very grateful to him for, so to speak, giving me the opportunity to spread my wings and demonstrate that, in fact, change and improving operational efficiency is truly a profound way of life that indelibly leaves a significant and lasting imprint on practically the entire rest of your existence.
Vyacheslav, so we first met, I believe, approximately 10 years ago during my significant business trip to the city of Norilsk.
That's right.
Yes, and here I think we have a truly interesting and significant intersection in the profound sense that we meticulously manufacture the essential tools that are so absolutely crucial for enterprises to significantly improve their operational efficiency, while you, in fact, were deeply involved from the other side in expertly implementing these powerful tools, meticulously organizing the work, performing precise calculations, and definitively demonstrating the tangible effectiveness of this advanced equipment. So I'd really like to hear from a first-hand perspective what challenges arise in terms of operation, implementation, and probably most importantly, in demonstrating the economic feasibility and effectiveness of using this type of equipment. Because as a rule, we are the manufacturer and the technical experts. At the enterprise, the technology side is also mostly handled by technical personnel. But in a market economy, decisions are made based on profit and revenue figures. And how do we move from technical indicators to economic indicators?
Yes, thank you for the question. There is a very clear methodology, a clear approach for how this kind of analyzer should be implemented. Of course, this comes from project activities. First, a diagnosis of the enterprise is carried out. Significant technological points are identified. Failures at these points, to be more precise, would be very critical for the company's profits. Of course, it's necessary to identify these points, and of course, we need to see how we can influence them because it's impossible to affect everything. And this approach in project activities allows us to understand exactly which analyzer we need to use, what we are going to measure, how we will influence it, and how this will ultimately affect the output of finished products. Because all the measures that are intended to be applied in operational efficiency, that are planned for operational efficiency, are ultimately aimed at improving product quality, increasing its output, and in the end, reducing cost price. Therefore, if the enterprise does not go through the cycle we are talking about, the diagnostic stage, the stage of developing measures, the stage of defending these measures, then of course the purchase will not happen. And if these measures are developed incorrectly, or if the enterprise goes through this process with certain deviations, then undoubtedly mistakes will be made that instead of positively impacting the company's EBITDA, will have a negative effect.
Yes, thank you. Here, I'd probably like to go a bit deeper into this particular subject. I absolutely agree with the crucial importance of improving overall product quality, but more often than not, even our valued customers frequently come to us with specific requests to install advanced analyzers on the tailings, as I thoroughly understand it, in order to effectively minimize significant losses. In other words, to see how much, so to speak, real money is flowing into the dumps, into the tailings storage, how much metal is not being extracted.
Yes, that's absolutely true. In the broader technological chain, it's probably quite difficult to accurately assess how truly reasonable and justifiable it is to focus specifically and exclusively on the significant losses that occur within the tailings. Because if you follow the same lean manufacturing methodology, it's preferable to organize the entire technological process into a single flow, for example, per unit of volume. And in this case, looking at what's happening in the tailings is probably the right thing to do, but I'm not sure how effective it is. From my point of view, it's better to start by examining the parameters of the input raw material and how variable they are. For this, you need to use a batch analyzer. Next, by applying the same geometallurgy concept, you need to ensure that the feed is done correctly. And then, after such metrics are in place, you can look not only at the tailings. Well, focusing on the tailings is probably a less effective solution. It's more important to look at the places where grinding occurred, where the first flotation cycle happened, and only then at the tailings. In this case, it will then be possible to properly influence those key points we've discussed, which need to be identified for the enterprise in order to provide it with the tool that will ultimately impact, as we said, the output of finished products, improve quality, and reduce costs. That's my opinion.
Yes, thank you. Yes, there's a saying, to manage a process, you need to measure it. It's clear that the more control points we have, the more information we have to make the right decision. So, if I understand your point of view correctly, if we only set up control points at the end, we can only state the fact that something went wrong, that we missed something, but figuring out exactly what went wrong and further developing this idea to find out at which stage the deviation from the technological regulations occurred will already be difficult. But additional analysis points will allow us to diagnose and deal with the situation in real time, right?
That's absolutely correct. Absolutely correct. You could say that this is a kind of approach. It's a post-mortem analysis. Why influence a process that's already finished? What's the point in that?
Probably from our own experience, at least what we've encountered is that when technology or personnel notice that something has gone wrong in the tailings, they start investigating, and that's a signal for them, yes, to figure out at which stage something happened. But naturally, without other reference points, it's much harder to do this if there are no additional data. Of course, if an enterprise has the capability, the number of such analyzers can reach 30 to 50 points, for example, which modern enterprises implement in order to, as I understand it, keep their finger on the pulse at every stage and control the progress of the technological process.
That's absolutely right. And here it's important to note the year the plants were built. Plants are not built just because there is a deposit. A very great deal of extensive pre-project work and comprehensive preliminary surveys meticulously precede this crucial stage. Powerful and influential research institutes become deeply involved, diligently developing precise regulations that carefully take into account the specific mineralogy of the geological deposit where the industrial plant will ultimately be constructed, as well as the advanced tools and technological capabilities available at that particular time. Since we are indeed talking about the historical past, we regrettably have to admit that the vast majority of these industrial plants were originally established during the 1930s to the 1950s, a period of significant industrial expansion and development. And this means that the essential tools, the necessary reagents, the powerful pumps, and the crucial air supply systems, in short, absolutely everything utilized in the process of flotation, were all meticulously designed with that very specific historical period in mind. And the research institute, of course, does not set as its goal to produce PhDs or create super powerful experts who will specialize in flotation, although people do reach that level as they work. When someone has worked for 15 years, naturally, they acquire the kind of expertise that allows them to properly manage and oversee the technological process. And these regulations are implemented with an efficiency of, 85 or maybe 75%. So, when we now come to this metric, how can we actually influence the technological process? There are several ways. Either the enterprise announces a revision of its technological regulations in order to take into account the new component base, the new tools that are emerging, and the new chemical compounds that allow the process to be carried out more efficiently. And this is precisely the point of contact that is opened up by installing a network of analyzers at the right significant technological points. This is exactly what gives an advantage to enterprise managers and operations directors who can positively influence the output of finished products. And the approach here should be exactly to provide enterprises with a complete tool, one that allows them to understand how they will achieve the targets set before them.
Well, if we talk about tools, getting closer to the topic of our analyzers, this is also a very sensitive and delicate issue. After all, there probably aren't really bad or good analyzers. There is simply an analyzer that is suitable for a specific task. Each type of equipment has its own golden ratio for a specific kind of task. Let's put it this way. I know you have extensive experience as an engineer working with equipment and various types of analyzers. Based on your practical experience, why do mistakes happen when choosing the final equipment, and how can they be avoided? After all, these are huge losses in terms of time, money, and resources from any perspective. So how can these mistakes be avoided? From my experience and from what we've encountered and discussed with colleagues, of course, non-ferrous metallurgy enterprises that extract copper, nickel, probably zinc and lead, they have been equipped with analyzers of this type for a very long time. There is an understanding, there is staff who work with them, but nevertheless, there are a number of industries or metals that are just beginning to take an interest. Probably first and foremost, these are enterprises that mine iron. They are only now approaching this issue, and enterprises involved in gold mining are not equipped at all. These enterprises lack in-house expertise and understanding regarding this equipment. Still, I would like to hear your advice and practical experience for such enterprises. What should they pay attention to, and how can they avoid these mistakes?
There is such a story. This, of course, concerns the structuring of business processes and the company itself. The breakdown in communication here often happens either at the procurement stage or during the discussion of technical issues, because as a rule, the person who needs the technological result, the technologist who needs to monitor those critical points, does not have the budget. The process is usually structured in such a way that first a person formulates a request. This request is then sent to a specialist responsible for operational efficiency. At this stage, there may be inaccuracies in conveying the specifications, the critical technological point may be incorrectly identified, or there may be insufficient communication between the operational efficiency engineer or specialist or manager and the technologist. That's one issue. Next comes the defense stage. In order for the shareholder to say, yes, I want to install not just one analyzer at this point, but as you correctly show, maybe 5, 10, 15 or 20. What's important is not the number, but the actual achievement. He needs to defend his position and show how things actually work, why these points need to be examined, and how we can influence them using all the new tools that have appeared, how we will change technological processes, how we will modify the regulations, and what the end result will be. All right. Let's say the defense was successful. All of this is then passed on, for example, to the procurement department. The purchaser actually doesn't know where to get it, so he starts searching. While looking for alternatives and considering different manufacturers, this communication, now at the second link in the chain, the purchaser, he rarely interacts with the technologist who needs the result. He finds several options, sends them for approval, and let's imagine that the person who needs this technological result goes on vacation. It's a completely simple thing. And the person who stays behind for him, the one who, from the perspective of operational efficiency, tries to get involved in the purchase of the analyzer. Here too, the question arises as to what can actually be approved. It's not at all certain. The purchaser can't just settle, for example, on Technoanalyt Pribor or on another company that also manufactures elemental analyzers. Still, it's a reduction, it's still some kind of comparison. And it often happened that all these steps were cycled through, and when there wasn't enough money, that is, they went over the budget set by the shareholder, very often failures occur at all these stages, and as a result, the shareholder's order is technically fulfilled, but the actual result is not achieved. Arseny Vladimirovich, but I know that you also have experience implementing analyzers. Obviously, since 2012, while the company has existed, you have sold and implemented a certain number of analyzers. From your experience, could you share if there have been any curious moments that, so to speak, made your hair stand on end?
So we do our best to avoid such situations in every possible way, and moreover, that's actually how this format came about, to convey the message that we are ready to share and help others avoid these situations. Because I'll say it again, every year we receive inquiries from a number of companies that have no experience operating this equipment and end up making very costly mistakes. I'll have another question for you later, Vyacheslav, on this topic as we continue our discussion. Specifically, how companies that haven't yet worked with this class of equipment and haven't accumulated internal expertise can develop and avoid making mistakes. Because the overall situation truly does indeed vary quite greatly and significantly from one specific sector to another, from one particular mineral to another, and so to speak, from one individual company to another company. I'd probably like to share with you our approach, how it has meticulously crystallized over the many years. Our method for effectively avoiding losses is actually very simple. Move progressively from simple to complex. There's absolutely no need to dive straight into the deep end. You should instead start moving forward step by step in well-defined stages, precisely to avoid such critical mistakes. What does this look like in practice? If we receive a task for which we don't have relevant field experience, something we haven't solved before, we ask the client to send us samples of the material that needs to be analyzed. Usually this isn't as labor-intensive as conducting industrial trials on site, and it makes sense to do it this way. Of course, there are certain difficulties for the client in preparing the samples, but still, it's not the same as running full-scale industrial tests. The client sends the samples in a specific format and according to certain requirements, and we conduct laboratory tests on the bench, in the lab, so to speak, and work out the methodological part.
Arseny Vladimirovich, before we move on, I have a question. Do you request the technological regulations from the enterprise that sends you the samples? Because, as a rule, these regulations specify the main parameters for beneficiation and recoverability. Do you at least take these into account from that perspective?
To be honest, no, because our task is to focus and provide a reliable working tool. The main direction of our efforts is measurement accuracy and equipment reliability, because enterprises operate around the clock, 365 days a year. The equipment must, let's say, have a tremendous margin of safety and work in extreme conditions. High temperatures, dust, humidity, all things that electronics, especially the kind used in metrological equipment, really don't like. It's very sensitive to interference, noise, vibrations. On the other hand, what we feel, see, and the requests we constantly receive always put measurement accuracy at the forefront. That is our main priority, and that's actually why this dialogue arose, to align our priority with the needs of the enterprise. So we focus on providing a working tool, a solution, so that at the very least, the customer doesn't have to worry that this tool is constantly breaking down, giving inaccurate readings, or operating with failures. If it's bulky, it's hard to implement. If it's expensive, that's another issue. So that's our focus. We work in this area. But of course, in today's realities and trends, it's clear that this is no longer enough. We're moving up another level. This is the level of expertise and competence I'm talking about. It's becoming probably a must-have, a basic requirement taken for granted. And in fact, we need to rise another step higher, where we not only provide the tool, but also ready-made solutions that show from point A to point B what we achieve with this tool. So Vyacheslav, thank you for the recommendation, but honestly, at this stage, and unfortunately, we often encounter this, even the basic requirement to fill out a questionnaire is, let's say, 50-50. There are often problems even here. Formulating and filling out the questionnaire, extracting information from those very regulations. For a number of enterprises, the range in which the content of certain elements can vary is not even clear. I'll go further. For some enterprises, for example, gold extractors, they might not even know what else besides gold and some basic elements might be present in the ore. So there isn't even, it would seem, the kind of understanding that should be there.
But by the way, that's exactly what the regulations address. There's never a situation where a pure chunk of nickel, gold, or copper is just lying in the ground. We understand that there is a certain mineral structure that over millions of years has formed and fused these elements together in a specific concentration. So, if I understood you correctly, you're saying that when we have a mineral, the associated issues arise because the client's specialists are unwilling to understand how the mineralogical composition is actually distributed and what needs to be paid attention to, including when preparing the questionnaire.
Honestly, I find it difficult to say what challenges the client faces, what difficulties they encounter. I don't think it's unwillingness. Rather, it's either due to being overloaded with work, or perhaps this information simply wasn't available. Maybe there was a need for it over the years, but it got lost somewhere, or it needs to be retrieved from the archives. All these difficulties exist, and here probably the key point for those who will be watching us is to highlight the importance of such aspects in the work done from a methodological perspective, because all these things, which may seem secondary to some, can actually add up to the final result and lead to mistakes that could have been avoided. That is, some information, for example, from the questionnaire, which might not be fully collected, could have very negative consequences in the future. For instance, the manufacturer might overlook or fail to anticipate something due to missing information. That's why, returning to our question about the difficulties and problems that arise, so in our case, we didn't have those issues answering this question because we moved step by step, working through things, progressing consistently from simple to complex. The first step is laboratory testing of the client's samples. We examine the methodological aspect. With minimal effort, we set up in the lab, the client sends samples, we prepare a report free of charge, conduct the research, and demonstrate that from a methodological standpoint, this equipment is capable of solving the given task. We mark this as a completed step. Next comes the stage of adapting the equipment to the specific location. Since this equipment is highly specialized, what is the main difficulty? The fact is, this is not a portable analyzer, not a boxed solution that you just take out and it works. It's also not a laboratory analyzer, which in principle is also a ready-made boxed solution you just take out and use. This type of analyzer requires personal, so to speak, customization, modifications for each client, adaptation to the specific physical location where it will be installed, integration with the enterprise's upper-level systems, and thorough methodological development. Therefore, as the crucial second step, if there are any significant doubts from the client or from our side, we then proceed with thorough industrial testing. Moreover, there is an option to deliver a new analyzer to the enterprise and conduct industrial testing with the possibility of subsequently purchasing the analyzer. That's it. Therefore, thanks to such careful and well-considered procedures, we are able to effectively avoid, so to speak, those potentially negative and undesirable situations that may unfortunately arise. But let me reiterate and repeat once again, based on my extensive experience and the valuable feedback I've consistently received over time, Such truly unusual and quite specific situations most often occur at large-scale enterprises that are primarily involved in mining iron ore, or at specialized gold extraction companies that are just beginning to seriously address this particular issue. I cannot definitively state that such peculiar oddities frequently happen at industrial plants dealing with the processing of common metals like copper, zinc, or nickel. After all, they have a significant background and experience there. People understand the processes, and such situations are usually avoided. Vyacheslav, I still wanted to return to the topic once again, starting from the difficulties faced by those enterprises that have not yet accumulated internal expertise. In your experience, is it possible and necessary for such enterprises to bring in, as it's fashionable to say now, consultants, consulting firms, and so on, companies that can provide, let's say, a comprehensive and exhaustive answer tailored to the company's needs in order to minimize the likelihood of making this mistake? After all, ordering such a report will cost significantly less, dozens, hundreds, even thousands of times less than purchasing this equipment. So I'm interested to hear your point of view on this issue.
Yes, thank you for the question, Arseny Vladimirovich. Here, it calls for defining the paradigm. It's no coincidence that we talked about technologists who rely on their technological regulations. It's no coincidence that we mentioned these are acquired competencies that allow you to manage the technological process. But here there's a very fine line where, relying on this paradigm and knowledge of the technological regulations, a person clearly understands, for example, what levels need to be set in the flotation machines, what reagent dosages to use, how much material to feed, and how the particle size affects the incoming material. This part allows you to avoid mistakes by following the regulations and to achieve the very efficiency of these regulations at those 85%. And a person, let's say, natively solves the problem by thinking, I'll set these parameters and everything will work out for me. And this is exactly the crucial part that has a significantly negative impact. This is the established paradigm that they steadfastly follow, and they absolutely do not want to even consider the profound thought that things could be done in a completely different and more effective manner. This is exactly what doesn't work well. And to prevent such mistakes from happening, as we've discussed, the approach here needs to be non-trivial. Of course, consultants can be brought in. Of course, it's very difficult to figure out what's wrong with the process in a short period of time. But there is another way, a gentler, and you could say a more correct one. In most companies, a production system is being developed. A business system is being developed. And what does this mean? This means that there are project teams on the ground who have long since analyzed the technological process and have long understood what is wrong with it, but they are not always able to propose clear solutions. This is where collaboration becomes important. First of all, you need to approach the client, offer them this kind of joint work with the project team, and once again dive into the work that was previously done, which they were unable to influence due to a lack of expertise. Since the product is indeed quite a specialized and intricate offering, in order to effectively implement it, you truly need to possess those very specific and highly refined skills and comprehensive knowledge that would thoroughly allow you to delve deeply into both the extensive documentation and the intricate physical aspects of the product itself. The thing is, there is usually quite a significant gap here, considering that the regulations were written back in the 1930s to 1950s, and by leveraging the experience accumulated by the project team, it will be possible to confidently make proposals. Well, first of all, it will be easy to identify those key technological points. In other words, this opens up the possibility of implementing the solution exactly where, from a custom perspective, it is important for the client.
So if we have correctly identified the point where implementation is needed, studied the regulations, and reached the stage of selecting equipment, there are still cases where something is purchased but it turns out to be the wrong fit and the equipment just doesn't work out afterwards. How can we avoid this and choose the best solution for the enterprise? From your experience, from what you've seen?
You know, it is truly the saddest thing when, in the pursuit of achieving a certain desired result, a specialist in operational efficiency, who unfortunately lacks specific in-depth expertise in the field of analyzers ultimately chooses a particular tool that in the end merely produces some raw, uninterpreted numbers. But there's no way to verify them, because in this race, driven by their own so-called expert opinion, what ends up being purchased is a black box. A black box whose calibration is unclear, whose readings are unclear, and there's no way to check its values. And in this case, no matter how competent the employees of the company that acquires such a tool are, it's impossible to do anything with this device without the manufacturer. And in my opinion, this is fundamentally the wrong approach. It simply shouldn't be this way at all. I believe that an analyzer should be supplied with all the necessary verification and calibration procedures, with the ability to change the measured parameters and recalibrate. In that case, you can achieve a very good result. Because in my experience, there was a situation where I had to deal with a black box. There were extensive and protracted negotiations that unfortunately dragged on for a great many years without yielding any tangible or meaningful result whatsoever. That is precisely why this situation arose. We probably need to seriously consider taking the customer's perspective and overall position into account after all. It's important to participate at the stage of filling out the questionnaire. And during the discussion of technological parameters, you need to see how mature the enterprise is, whether it operates according to the geometallurgy format. And in this case, you can guide the customer toward the result they expect. And secondly, you might even be able to get ahead of the curve and exceed the customers' and clients' expectations in order to deliver exactly the result they want. Of course, taking into account the interaction with the operational efficiency project team, which already exists at most enterprises.
All right, thank you very much. So to sum up, one of the absolutely crucial and most important criteria is that a metrological instrument, in order to be truly effective and reliable, should always come with comprehensive and sufficient documentation for its independent calibration and also for its self-configuration. And it is essential to have a complete and thorough understanding of precisely how this particular device is calibrated, how it effectively functions, and so on and so forth.
And if that's not available, then the customer should be offered training. Let it not be, say, an extensive course in advanced physics and mathematics, but rather concise extracts that would allow specialists who will be servicing this device to form a clear strategy in their minds, what the accuracy of the readings depends on, and what steps need to be taken to achieve that accuracy. That's my opinion.
Yes, thank you very much. Perhaps here I would like to add my perspective based on my own experience. For more than 12 years now, I have also been visiting various enterprises directly for implementation purposes. Probably your case is unique in that there are still enterprises where there are resources and specialists who are willing and able to delve into the black box. Unfortunately, such an ideal situation is no longer found everywhere. Or to be more precise, it's far from being the case everywhere. We actually tried to go down that path ourselves. We would come in and try, so to speak, to cram the uncrammable into the specialist heads. But first of all, let's say my 10-year background in this field, both from my first degree and then from my PhD dissertation, it's hard to condense all that into a 1-hour lecture and pass it all on to overload someone with it. That's the first point. What takes decades to synthesize is hard to cram into 1 hour. In fact, it's impossible. The second point is that we can't escape staff turnover at the factory. There were situations where we would come train people, then 3 months later the person would quit, and it becomes obvious that basically maybe we need to solve a different problem first, like making sure there's someone to train, that the person actually stays in the position. That's it. As I see it, there's still another problem. There are different types of analyzers. Right now, we mainly distinguish 3 basic types that are available on the market: X-ray fluorescence analyzers, laser Libs analyzers, and accordingly, neutron analyzers. This is also a very interesting and indeed crucial aspect, and quite often this is precisely where, so to speak, the fundamental starting point truly lies. A profoundly significant and influential factor in making well-informed decisions about which specific analyzer to ultimately choose. First and foremost, you need to precisely determine, so to speak, which of the various physical or nuclear physical methods will be most optimally suited and effective for a particular enterprise or specific operational context. So I would like to emphatically add to this fundamental and crucial basic point that, in my considered opinion, the very first and most important thing you absolutely need to do is to fully understand the comprehensive range of available equipment and the intricate underlying principles upon which it effectively operates. Then you need to look specifically at the characteristics of the enterprise and the materials it works with. And then within this matrix, you need to observe and analyze. In fact, we once tried to conduct such an analysis a long time ago and published some materials. But either the topic is very specific and difficult to grasp, or perhaps our society is surrounded by such an informational and marketing fog, a kind of noise where everyone claims to have the best, everyone says their equipment is the best, and as a result, the customer often loses their bearings and doesn't know which way to go in this fog. In other words, as the saying goes, everyone looks out for their own interests first. The manufacturer praises their own equipment, their own type of analysis. That's how it is. And here, of course, as I see it, it would make sense to simply seek out a consultation to get some kind of basic, comprehensive answer, maybe a few pages long, that would help set some reference points for these types of equipment tailored to different tasks. This is an important and necessary task for a number of enterprises that are approaching the issues of operational efficiency and the implementation of this class of equipment, because there are a lot of nuances that need to be taken into account. Often we find ourselves reverting back to a familiar and deeply ingrained paradigm, a way of thinking where, in our conventional and established approach, the item or service that carries a higher price tag is almost invariably perceived and considered to be of superior quality or value, and therefore inherently better than its less expensive counterparts. In other words, we're used to thinking in these terms. If something is sold at a higher price on the market, it might be better. But when it comes to analyzers, this doesn't always hold true. Equipment based on different physical principles can be several times more expensive, but that doesn't mean it's more accurate or better. It's just different. It's suited for other tasks where other analyzers can't operate. But that doesn't mean that for your specific task it will be significantly more accurate or better. In practice, I often encounter situations where, well, let's say very experienced and skilled salespeople somehow manage to, let's say, smooth things over and frankly sell a solution where we're basically using a microscope to hammer in nails. That's the kind of level we're talking about. And this, as I understand it, is also, from the perspective of operational efficiency, a very detrimental decision for the company when they buy a tool that may not really be suitable for the task that actually needed to be solved. And from this point of view, perhaps by turning to such highly specialized organizations that have been on the market for a long time, and by investing a small amount of resources and money, you can, so to speak, play it safe. Lay some groundwork to avoid making a mistake when purchasing the wrong equipment. And what do you think about this? From this perspective, how can this be integrated into the decision-making process? Can such consultants be brought in by companies to provide advice? Honestly, I would really like to share our expertise and experience with a number of large, well-known companies that reach out to us to communicate this to them and so on. What will work for them, what won't, and why. But year after year, we keep getting requests from marketers for market benchmark studies, for comparisons of various analyzers, different ones actually, based on physical principles, on different parameters. So it's clear that these requests are coming from people who are not deeply immersed in this context. And the work they do and the information they provide, management didn't have a clear understanding before, and they still won't, because the initial task was set, let's say, with the wrong focus. So what should be done in this situation? This is the question that interests me most, because I see the same situation repeating year after year, and inevitably mistakes still happen, and a number of enterprises just can't seem to break this vicious cycle.
Well, Arseny Vladimirovich, in response to your question, what is important to note here? Most customers, they just want to get a number. They don't understand how that number was produced by the analyzer. And for that, it's necessary to explain the methodological part, how the analyzer is trained. And then there's this question, the benchmark, which keeps coming up, right? That's an important issue. Because in reality, if you lay out several sheets for the customer with one analyzer, another, a third analyzer, they'll look at what conditions they need to provide for measurement and at the number that each analyzer will show, which once again emphasizes that there should somehow be a mechanism that would allow for the verification of the specialists at the factory where the implementation is taking place. If they don't understand and are far removed from this area, if they lack competence or experience, again, this comes through training, through engagement, and most importantly, there really needs to be a certain business idea behind all this. In other words, it's important for the client not to just sell that final figure they're expecting and not to disregard the middle part where that figure is actually generated, but rather to sell the technological result so that they can engage with project teams and take on those cases that they previously couldn't bring to implementation. And ultimately, the shareholder needs to see what exactly they are acquiring and why. And the client needs help with all of this. This is my expert opinion, which actually demonstrates how the paradigm is shifting, highlights our involvement in identifying key technological milestones, and illustrates our approach to the business concept, where the client is not buying analyzers or digital solutions per se, but rather what will deliver the parameters that, if you will, are embedded in their KPIs for operational efficiency. These are the parameters by which they either improve the quality of the finished product, increase its quantity, or achieve both while reducing production costs.
Yes, Vyacheslav Mikhailovich, thank you. Here, I truly believe that we complement each other perfectly and seamlessly as a cohesive team. That is to say, we are very much like expert manufacturers of a highly effective and specialized tool designed for a very specific and particular task. And you, as an invaluable specialist with a profound background and extensive experience, are uniquely positioned to suggest, well, probably the absolute best practices, precisely how it can be most effectively implemented, how it can be optimally utilized, and how it can further significantly enhance and substantially strengthen, so to speak, our comprehensive offering. This ensures that it's not just a mere tool, but rather a complete, ready-made, and robust solution that delivers clear, quantifiable, and measurable results at the output.
By offering an integrated solution and providing a comprehensive answer that is valuable to the shareholder, this task is accomplished, just like many others we've discussed today.
The golden ratio of X-ray fluorescence equipment is also one of its broadest applications, including for liquid process products such as pulp. We understand that there is a certain cumulative error which is determined by a combination of errors from the process analyzer, the laboratory, the representativeness of the analysis, and sample preparation. But the key question, and here I agree with you, is what margin of error is acceptable for us? Acceptable in order to achieve the desired effect, the desired result. And what kind of result? Yes, we have a patent that combines 3 different solutions: hardware, design solutions, and methodological solutions, all together, which we are now patenting in 18 countries around the world